So far, we've only been making points, lines, and curves. Now we need to make surfaces. Copy this part, define surfaces, save, reload the script, tools, options, geometry, visibility, and toggle surface labels. Now you can see that planes 1, 2, 3, all the way till plane 16 are made. Now, once the planes are defined, we can actually start making the mesh 1D, 2D. But as you can see, the mesh is quite coarse and different from what we expected from earlier. Now we copy this part, define point distribution along edges. We'll come back to this later. Press save, reload script, 1D, 2D, and now we see a much denser grid from previously just now. But as you can see, the grid is still made out of triangles instead of structured rectangular cells that we want. For that, copy the next part, master command to specify structured grid in specific planes, Control S, save, reload script, 1D, 2D, and now we see structured grid. Our mesh is still 2D, so we're going to copy the next part of the script, extrude mesh into 3D geometry with span of 1 unit, save, reload script. Now we have a 3D volumetric mesh, 1D, 2D, 3D. So now let's come back to the point distribution along edges. Top vertical edges going left to right is currently made up of 16 segments. Let's try changing that to 50 and see what happens. Save, reload script, 1D, 2D. Now, this top section is now divided into 50 along this edge using a progression of 1.105. Let's see what happens if I change this to 1.0, save, reload script, 1D, 2D. Now we have a uniform distribution. Similarly, if we change the bottom to 50 with a progression of 1.0, save, reload script, 1D, 2D. Now we have 50 segments here, uniformly distributed. We can similarly change the left horizontal edges from 16 to 50, save. And now you see this part has more cells using a progression of 0.9. That means the right horizontal edges going top to bottom. Let's try changing that to 100. Save. Reload script. 1D, 2D. Now this part is divided into 100 sections in the horizontal direction. Let's go back to the original settings. Now you can see from here that the cells are more densely populated around the cylinder and gradually less dense away from the cylinder, and a relatively dense distribution in the downstream. This is because we know that the interesting flow will develop mostly around the cylinder and downstream of the cylinder where we expect the vortex shedding. So just like how we change the settings around the domain here, we can also change the distribution and progression along other areas, and I encourage you guys to explore these settings on your own. When you are modifying this mesh template, it's important to keep in mind that you should keep the cells smoothly distributed. What I mean by that is the cells connecting from each boundary should have small changes in their sizes so that they are sort of smoothly created. For example, when we changed this part to 50, save, we ended up having very thin cells here and then a sudden jump to larger cells here. This kind of jump in the cell size will lead to weird looking solutions and even possibly numerical instability. So making sure that your geometry is smooth is very important. Let's copy the last part here, save, reload script, 1D, 2D, now 3D. And what this part is essentially we're defining where the fluid volume is inside the mesh. We can check this by first of all going to Tools, Objects, Geometry, Visibility, and Volumes. And you can see the yellow spheres represent the different volumes that we have created. Now we move on to the final part where we start labeling the boundary patches: inlet, outlet, top and bottom, wall, and sides. Geometry, physical groups, add, and let's start with inlet. And now I can select the different patches that make up the inlet, such as this one here, and this one here. After selecting them, press E to end the selection. And now if you go back to your script, now you'll see that this line got added called physical surface inlet. And now we're going to do this for all the relevant boundary patches. So let's do one for the outlet, which will be this one, and this one. Press E. And now we have an outlet patch. Let's do top and bottom, which are this one, this one, this one, this one, this one, this one. Top and bottom, press E. And that gets added here. Let's also do the cylinder walls, which would be, this might be a little bit tricky, this one, this one, this one, and this one. Yep, those are the cylinder walls. Press E. And the sides of the domain, which would be this, 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 these, E. All right. Now let's go to Tools, Visibility, and now we have the volume from before, but also 1, 2, 3, 4, 5 surfaces that we have created. For example, if you only click on inlet, press Apply, you will see the inlet surfaces, inlet and outlet, top and bottom, walls, and sides.